In this video, I'm going to walk through the process of stoichiometry. Really, stoichiometry revolves around this map. Now, what we have to have before we can even use this map is a balanced chemical equation. Okay, so we have to have a balanced chemical equation. And the reason for that is because in order to figure out moles of one to moles of the other, I've got to have coefficients from that balanced equation to work with. So what I'm going to do is I'm going to walk through the process of each of these processes going from left to right, because that's really the way this whole process works, is we're going left to right. We start off with our given, we work to our unknown. So when we are given a problem, in the problem, we've got a bunch of words most of the time, and then we've got some numbers, and it says that something and something react to form something else. Now, what they're doing in these problems is they're giving you a lot of information, some of which you don't even need to be able to solve the problem. So in these problems, the essential thing to do is be able to get from one substance, like you're given, to a substance like an unknown. When I say an unknown, that's whatever it's asking for. Okay, so anytime I'm referring to the unknown, it's whatever we're being asked to find. So let's say that, for example, it's asking us to find particles of the unknown. And it gives us particles of something. So what we're going to have to do is we're going to have to figure out our route to get from point A to the other side of the world over here, to this point. So what we're going to do is we're going to be doing some multiplying by fractions. So the first multiplication that we would do, going from particles given, we're going to multiply by 1 mole divided by Avogadro's number. So see, now I'm using this little arrow as my division in that fraction. So I'm essentially just multiplying by a fraction from whatever I'm given. That gets me now into the moles of my given. In order to get to my moles of my unknown, I have to use coefficients from my equation. The coefficient of my given goes on the bottom. The coefficient of my unknown goes on top. And so here again, we are multiplying by a fraction. Now we're going to get from, because we've canceled out moles of given, we're now in moles of unknown. To get to particles of unknown, I've got to multiply by another fraction. This fraction is going to have the particles on top and the mole on bottom. So here again, we're just dividing 6.02 times 10 to the 23rd by 1. Here, this gets us into particles. That's how we do stoichiometry, from particles of something to particles of something else. Now I'm going to remove these and keep what's in the center though. So I'm going to go ahead and just remove this, because now my given that is in my next example I want to talk about is not in particles, it's in grams. So let's say that the problem actually gives us a mass. However, it's asking us for particles. So in this situation, really, I could have kept over here my particles on top and one mole on the bottom. Okay, so I'm still going to have this component. But going from grams now, so I'm not concerned about these two down here, I'm concerned about grams. So I'm going to put my 1 mole on the top of my fraction, and I'm going to put the molar mass in grams on the bottom. This allows us to divide, I'm going to turn this image just a little bit, divide by molar mass in grams. That cancels out grams and leaves us with moles of our given. Now we can follow the route the rest of the way. So you see here in the middle, it's always the coefficient of the given on the bottom, the coefficient of the unknown on top. That's after you've balanced your equation. So if you're struggling with balancing chemical equations, you need to go back and review that to really succeed with this. So let's say instead of asking for particles, let's say that it said that we're dealing with a gas, and this gas is at standard temperature and pressure. Well, if you remember when we talked about standard temperature and pressure, that's referring to this one, gas at standard temperature and pressure. So when we're given this next one, it's asking us, and I'm just giving you an idea of a type of question it could be asking. This next one is going to ask us instead to go from grams of a gas. It wants us now to tell how many liters of that gas or of a different gas are produced. Okay, so we're going from one substance. Let's say that we had a problem like a combustion problem, where it gives us a mass of some sort of reactant, some hydrocarbon, reacting with oxygen to produce CO2 and H2O. And it asks, at standard temperature and pressure, if you have so many grams of this reactant, how many liters of carbon dioxide would be produced? That's when you would have to follow this route to go to liters of your unknown. So to do this step, I'm going to have my 1 mole go on the bottom, and my standard amount, my molar volume, is for every 1 mole of gas at standard temperature and pressure, there are 22.4 liters of space occupied. So this is how we go from point A of our known, our given, to point B, whatever our unknown is. If it gives us moles, and it wants moles, it's one step. We just use our coefficient. If it gives us one of these over here, and it asks us for moles of a different substance, we don't have this last step over here that I'm covering up. But sometimes we'll be given one that asks us to go from all the way over this side of the world to the opposite side of the world, and we have to figure out how to go all the way across. In those cases, you're going to have 3 steps. So you could have 1 step, you could have 2 steps, or you could have 3 steps with these chemical equations and these questions that you could have. So in the next video, I'm going to go through some examples of some problems that would be asking you this type of stuff.